So what we have here is we have three forms of a linear equation. You don't need to write all of this down. I really am just focusing on this first circle. Slope-intercept form is one way that we write linear equations. And typically we think of that as just y equals mx plus b, where m is the slope and b is the y-intercept. And I actually have this on a separate page for you to write down. Point slope form is a little bit different. That's when you're given slope, again, which is m, and you have an ordered pair, like a point on the line that you know of, not necessarily the y-intercept, but some other random point. And then our third form here is standard form. That's what we talked about last week in our day 3 lesson. And that's where we would do the cover-up method to find the two intercepts, and then graph using standard form, our intercept method. So today we're going to focus on slope-intercept form instead. All right, so here's for our notes. So what is the slope-intercept form of an equation? Or you could just write slope-intercept form on the left-hand side. And on the right-hand side, please copy down y equals m times x plus b, just like this. Typically, we just say mx plus b. You will want to note that m, so this variable here, excuse me, this letter, this constant, is the slope, and the letter b then represents the value of the y-intercept. In other words, where does your line that you're graphing, cross the y-axis, okay, that vertical axis. So what we're going to do, and feel free to pause it if you need more time to copy things down, but we're going to go through some examples, and we're just going to work on identifying, okay, so what number is the slope and what number is the y-intercept on several examples. So let's start here. Number 1, identify the slope and y-intercept from each equation. We have y equals 2x minus 3, and notice if we look at our original example up here where m is, it's that number that's right in front of the x. You could call it the coefficient of x. Or sometimes we just say it's the number that's being multiplied by x. And in this case, that's going to be the number 2. So the slope of the line is 2, or if we want to think of it for graphing purposes, we can say it's 2 over 1, because any number can be turned into a fraction if we just put a 1 underneath it. So then the y-intercept is the value that's being added at the end. In our form up above, it just says plus b, which represents the y-intercept. And in this case, it's going to be the minus 3 or negative 3. So keep in mind, this equation doesn't have addition in it, but we could rewrite this so it does. So instead of saying 2 times x minus 3, we can think of it as y equals 2x plus negative 3, because we know that adding a negative value is the same as subtracting a positive value. So that's why our y-intercept is a negative 3 and not a positive 3. Let's look at number 2. We have y equals 5 plus negative 1/3 x. And don't be tricked. In this one, we end up having the slope, which is the number, again, that's multiplied by the x, right in front of the x. And in this case, we have it as negative 1/3. Hey guys, they are still at their grandparents' house. Well, I don't know, they probably won't be back till like dinner time. So I don't know if they'll still be in the session. Okay, sorry. All right, for number 2, we have y equals 5 plus negative 1/3 x. And don't be fooled on this one. Notice that the x is in a slightly different location. It's not y equals something x plus another number. The x is kind of at the end. So what we want to do is keep in mind, you can rearrange terms in an equation as long as you're keeping the signs correct, that we can switch these around. Basically just do a flip. Let's say it's y equals negative 1/3 x, and then we put the plus 5 at the end. This helps us see that the slope of the line, again, that's the number that's being multiplied by x, is negative 1/3. And the y-intercept, which is the value being added at the end, is positive 5. So the slope is negative 1/3, and the y-intercept is positive 5, or the point 0, 5. All right, we're going to go on to the next page. Feel free to pause if you need time to copy those down. All right, for number 3, we have y equals x. Now, on this one, we don't see any numbers at all. However, there are two numbers there. They're kind of hidden invisible numbers, and they're actually different values. So if we want to try to rewrite this using values, y equals something times x plus something, let's think about what numbers could we put in those blanks to make it simplified to just be y equals x. So in the first blank, we want to think about what number is multiplied by x to just get x. Well, something times x to keep it the same, that number has to be 1, since 1 times x is just x. Now for the y-intercept, it wouldn't be 1 in the blank. It's not just always, if you don't see the number, it's 1. Because think about, what number can I add to x to keep it x? In other words, what do I add to something to not change it? And it has to be then the number 0, because anything plus 0 is itself. So in this case, the slope is just 1, or for graphing purposes, we can call it 1 over 1. And the y-intercept is at 0. For number 4, this equation is actually written in point-slope form. It's completely different than what we're used to seeing. It's not even like just a y equals equation. So before we can tell what the slope and the y-intercept are here, we want to do a little rewriting of the equation. So we're going to start by distributing the right-hand side. And this is something you're going to learn in a future lesson. We're going to distribute. We get y plus 8 equals, and we distribute the negative 3, so we get negative 3x. And then when we distribute, remember you're multiplying a negative 3 times a negative 5 gives you a positive value, positive 15. Okay, so that's step 1, is distribute the right-hand side. Step 2, we want to get y by itself. Okay, this is just like solving literal equations. I just want to solve for y and get it by itself. So if I want to undo the plus 8, I subtract 8 on each side. And let's see, what would I subtract 8 from? Well, 8's just a number, so I subtract it from the other number. And that's going to leave me with y equals, because that's going to cancel. I bring down the negative 3x, and then I do 15 minus 8, which is positive 7. So looking at my equation, I can see that my slope, again, that's the number right in front of the x, is that coefficient is negative 3. Or, again, for graphing purposes, we can think of that as negative 3 over 1. And then my y-intercept is just positive 7. Number 5. This time we just have the equation y equals 6. Let's see. Y equals something x plus something. Okay, so I got to think about what number do we multiply by the x here to make it. Oh, wait a minute, there's not even an x in the equation. So what do I multiply by x to make it go away? So if I multiply it by 1 times x is still x. So in this case, I think I actually have to multiply it by 0. Because then 0 times x is 0. And I have to figure out, well, what is the y-intercept? What is this number over here? So that when I add all this together, I get 6. Well, it's got to be itself. It's got to be 6. Because 0 times x is 0, and 0 plus 6 is 6. So simplified, it says y equals 6, but unsimplified, the slope is 0, or for graphing purposes, we can think of it as 0 over 1, and the y-intercept is positive 6. All right, last one, number 6. We have x equals negative 2. And this one is actually kind of a trick question, because if we want to try to get our equation to read y equals something times x plus something, like we've kind of been filling in on the other ones, we're going to have a little bit of a problem there because we don't even have a y in the equation. There is no y. It's like being 0 y. So the trick here is that we actually don't have a y-intercept. So we're just going to say not applicable, or NA. And the slope on this one is that one slope that we talked about a few weeks ago, where it's not a number. Okay, there's no value to it. It's not that there's no slope. Okay, that's different. That's a slope of 0, like problem number 5 here. This type of problem is an undefined slope. That's the line that would give us a perfectly straight up and down vertical line. Okay, and it can be a little tricky. So if it's just x equals a number, any number, the slope is undefined, and there actually isn't even a y-intercept involved. All right, feel free to pause if you need more time to copy those down. So now let's get into our second learning target. How do I graph using the slope and the y-intercept? It's broken down into a number of steps. So here is our first step. First thing we have to do is we have to, just like we did practice there in several examples, identify the slope from the equation and the y-intercept from the equation. So we start there. Step 2, we want to go ahead and plot the y-intercept. Okay, please remember, the y-intercept is on the y-axis. So that's that vertical line that goes up and down, kind of like an old-fashioned thermometer. Okay, positive goes up, negative goes down from the origin. Then step 3, this is my favorite part. We use the slope to plot more points. Okay, and we can use it over and over and over again, depending on how big of graph space we have. Okay, we just use rise over run to plot more points. And then last, we just make sure we draw the line that goes through the points. All right, so feel free to pause that and copy down your 4 steps before we look at our last few examples on graphing. All right, and last we have some examples. So graph y equals 5 halves x minus 1. So the first thing we want to do is identify what is the value of the slope. So slope is m. And what is the value of the y-intercept, or b, in the equation. So as we look at this, we remember from before that m, or slope, is the number that's multiplied by the x, or the number right in front of the x. So that's the fraction 5 halves. The y-intercept here is the value that's being added after that. So it's because it has a minus 1, that's like plus a negative 1. So the y-intercept is actually negative 1. Remember that that is the ordered pair, 0, comma, negative 1. So on my graph, I have my x-axis and I have my y-axis. And the steps that we just wrote down from our notes are to start by plotting the y-intercept on the y-axis. So I have to start on this line right here. Okay, it's an absolute requirement. You have to start on that line. You can't start anywhere else when you're graphing with this method. The very first point you should draw should be right on that vertical line. And we want to make sure that we're using the right value here. So negative 1. So on my y-axis, negative 1 is when I go down 1 space from the origin. I even like to label it. That's my starting point. Okay, that's my y-intercept. From there, I'm going to use the slope. Okay, the slope's not a point on the graph anywhere. The slope, think of it like it's the directions. It's how I get to all of the other points on this line. So I am going to rise 5 and run 2. Now think about it. These are positive values, right? Positive 5, positive 2. If I am going to rise positive 5 from my y-intercept, positive rise, I have to go up. Okay, positive rise goes up. So I'm going to go up carefully, 5 spots. So 1, 2, 3, 4, and 5. Takes me to about there, but I don't want to make a point there yet because I also need to run positive 2. When I run, I either go left or right. Okay, left is if it's negative, right is if it's positive. So I'm supposed to run to the right 2 spots, and I want to draw my point, my next point, right there. And I did a rise of 5 and a run of 2 to get there. Now, That's only 2 points, and technically you can draw a line through any 2 points, but this is where you can plot more points very quickly. You just repeat that exact same process. You rise 5 and you run 2 more. So rise positive 5 means to go up, and you run to the right positive 2. And I plot another point right there. At this point, I can't make any other I can't plot any other points because I'm going to run out of space. I can't count up 5 more. I could go over 2, but I can't go up 5 as well. Maybe somewhere way up here. But what we can do is we can actually work backwards. So instead of having a rise of positive 5 over positive 2 for a run, we can think of this as being negative 5 over negative 2. Because remember, whether you divide two positive numbers or divide two negative numbers, the result is the same. It's a positive value. So I could think of the slope here as having a rise of negative 5, which means I actually go down 5. But if I do that, I have to make sure I'm using my run of negative 2, which means I then go to the left 2. Notice, if I do that, that's one of the points in my line. So I could keep doing that. Down 5, left 2. Down 5, left 2. And I think if I scroll down on my screen, I can get one more to fit. Down 5, left 2. All right, so now let me get rid of my arrows here. So we can see just the points, mostly. There we go. And look at that, they line up quite nicely. So the last thing we have to do is draw a line with arrows at the ends. And let's do that one. Draw a line through the points. And there we have it. That line represents the equation y equals 5 halves x minus 1. All right, let's take a look at another one. Number 8, we have y equals 3 minus x. I want to start by actually rewriting this equation so it models more of my slope-intercept form. So what we're going to do is we're going to take our terms and we're going to do a little switcheroo because I don't want the x part at the end. I want it first. So I'm going to make it negative x plus 3, because remember the 3 is positive, so I use a plus sign there. And I also want to remember that if it's negative x, it really means negative 1x. So here, my slope, m, is negative 1, which for graphing purposes, I want to think of it as negative 1 over 1. And my y-intercept, or b, is positive 3. Okay, or that would be the point 0, comma 3. So I want to start by plotting my y-intercept. Remember, you have an x-axis and a y-axis. So I always have to start on the y-axis, and this time I want to go to positive 3. So let's see, positive numbers are up. 1, 2, 3. I'll label it as well. There's my y-intercept. That's one point that I know has to be on this line that I'm graphing. Now another point that ends up being right on the line is if I use the slope to plot the next point. So remember, it's rise over run. So rise is negative 1. Run is positive 1. Okay, so they're not both negative this time. When my rise is negative, think about that. Which way am I going to go? If my rise is negative, do I go up or do I go down? And hopefully you're realizing that, well, normally rise goes up. Like the sun rises in the morning, it goes up in the sky. But if it's a negative number, that means it's actually going down. So I want to go down 1. And because my run is a positive value, run means go left or right. But in this case, positive means I have to go to the right. So those are the two directions I have to go before I plot my next point. And I don't restart at the origin. I start at the y-intercept. That's why we have to plot that first. So I want to go, let's see, rise negative 1 means I go down 1 square. one space. And then I run positive 1 means I go to the right 1 space. Oh, simple enough, right? Down 1, right 1, down 1, right 1. Look at how quickly we can plot all these data points that are on this line. And I'm going to go all the way till I'm out of space. There we go. If I want to do the opposite of that and kind of fill in the other half of the graph up here, I just reverse the directions. So I think of my rise as positive 1 and my run is negative 1 because it's the same overall value. Okay, if I divide those two numbers, a negative divided by positive or positive divided by negative, I just get negative 1 as an overall value. So this time I would go up because my rise is positive, but I would have to go to the left because my run is negative. So I go up 1 and back 1, up 1, left 1, up 1, left 1. And notice those points line up nicely with the other points that we drew. And this time I'm going to go ahead and just draw my line freehand. So sorry, it might not be very good, but arrows at the end to show the line goes on forever. Okay, so even if we stop our points short and only draw a few on each side, we know that the line does go on forever. All right, there's number 8. Number 9, y equals 6. Now, we had one kind of like this in our examples earlier. We just have to remember that we're finding the slope, which is the number in front of the x, and the y-intercept, which is the other number that's not multiplied by x. So in this equation, the 6 is the number that's not multiplied by x. Do you remember what the slope is? So hopefully you were reminded that if I want to make that x go away and just be gone, I can't multiply it by 1 because 1 times x is still x. I have to multiply it by 0. So in this case, my slope is 0, or 0 over 1 for graphing purposes, and my y-intercept is 6, which would be the point 0, 6. So for graphing, I have my x-axis and my y-axis. I always start on the y-axis, and my y-intercept is positive 6. So I go up to positive 6, and I plot my y-intercept. Not a bad idea to also label it. And then next, I use my slope to plot more points. Now, on this one, my rise is 0. So if I go a rise of 0, that means I don't go up or down at all. I can't go up, I can't go down. But I can run positive 1. So if I rise 0 and run 1, it's just going to go to the right. So basically, it's building this flat line, this horizontal line, right across it. It goes through the y-axis right at 6. So again, the equation y equals 6 is a horizontal line with 0 slopes. Remember that type of slope? There's positive, there's negative, there's 0 slope. And that's where we have a flat line. Like you're on the graphic, it was the guy walking along the top of the cliff, just walking on flat ground. All right, and our final example, number 10. This time we're graphing the equation x equals negative 2. This is also like one that we saw earlier with our examples, where we found out that if you can't write it as a y equals equation, that means our slope is undefined, and it will not have a y-intercept. So this one's a little bit harder to use that slope-intercept method of graphing because you can't. Instead, let's use a table of values to help us see what this would look like. Now, all we know about this equation is that x is negative 2. So we're going to go ahead and start by saying, all right, well, x has to be negative 2 all of the time. It can never vary. My equation says x equals negative 2. Right? It can't change. They're telling you what x is. They're not telling you at all what y is, so y could really be anything. The y value could be negative 5. The y value could be a positive number. So we'll just make up a couple, and let's see what happens when we plot these points. Now, plotting points is different than counting slope. Plotting points is you plot them as x, comma, y. So go in the x direction first, then go in the y direction. So for my first ordered pair, I see that I have x is negative 2, so I go to the left 2. And then my y coordinate is negative 5, so I go down. 5 spots, and I make a point. My next ordered pair, I have x is -2, and my y coordinate is +2. So I go left 2, up 2. And my third ordered pair here, I have an x value of -2 again, and now I have a y value of 6. Well, let's see, what kind of a line could possibly go through all three of those points at the same time? That line would have to be perfectly straight up and down, or vertical. And remember, that's the type of slope that we would have. It's a vertical line that never crosses the y-axis, so it doesn't have a y-intercept. It kind of runs parallel to the y-axis instead.